Hello everyone, I'm going to discuss about Zener diode and its characteristics. Before that, let me introduce myself. I am Satya Abhinay and I'm from ECA section. My register number is 403. These are the contents we are going to discuss about in this seminar. First, I will discuss about what is a Zener diode and its construction and symbol. We will discuss about advantages and its limitations and we'll conclude the session. First, introduction to Zener diodes. What is a Zener diode? A Zener diode is a special type of semiconductor which is designed to work in only reverse bias conditions. Unlike ordinary diodes, Zener diodes are heavily doped diodes. Their key function is to maintain a stable voltage across their terminals even when input voltage varies. This is how a Zener diode looks. It is constructed using a heavily doped p-type and n-type semiconductors. The Zener diode has a p-n junction similar as a diode, but the doping level is much higher when compared to a regular diode. Silicon is the most common used material in the preparation or construction of Zener diodes. Now we will discuss about operations and its working principles. Uh, Forward bias operations. When we are operating a Zener diode in a forward bias, the Zener diode behaves like a standard PN junction diode, which means it allows current to flow after its typical turn-on threshold. It is about 0.5 diode. Now, when it is operated in now, what is a Zener breakdown? The Zener breakdown occurs at low voltages. Typically, it is less than 6 volts. Due to the strong electric fields and tunneling of electrons in heavily doped diodes, Zener breakdown occurs. We will discuss about avalanche breakdown. This avalanche breakdown is quite opposite to Zener breakdown. It happens at a voltage higher than 6 volts, and this breakdown mechanism is due to the collision of ionization of carriers. This is very common in lightly doped Zener diodes. Now, what is voltage regulation? In a breakdown voltage region, Zener diodes maintain a steady voltage over a wide range of currents, making them ideal as voltage regulators and reference devices. We will discuss VI characteristics in two parts. That is, one is forward region, another is breakdown region. In forward region, the Zener diode behaves like a regular PN junction diode with a threshold or knee voltage of about 0.7 volts for silicon types. Here, the current reaches rapidly beyond this point. That means beyond 0.7 volts for silicon types, it will increase slowly, and beyond this point, the current will increase rapidly. In reverse bias region, only a small amount of current flows, which is also called as a leakage current. When the voltage reaches the Zener voltage, the current grows rapidly in the negative direction, as we see in the picture. The breakdown region is characterized by almost constant voltage regardless of current variations. That means the voltage will be constant regardless of the values of the currents. Advantages and limitations of Zener diodes. First, we will discuss about advantages. The first advantage of the Zener diode is that it is an excellent voltage regulator. That means it is used to regulate the voltage. That means it is used to control the voltage value. And it is relatively inexpensive and widely available. That means it is very affordable. It is available at affordable costs and very available at different places. The size is also very small, making it portable. The fast response time for over voltage protections. Zener diode. The first limitation of the Zener diode is its power dissipation. Zener diode can dissipate significant heat if the current is too high. That means when we supply a current of with high values, it may overheat, which may result in damage of the Zener diode. It's now we will discuss about temperature dependence. Zener voltage can vary slightly with temperature. That means Zener diodes are not suitable for high power applications, as we saw in the first limitation. Without additional components, we cannot use it in high current capacity circuits. Noise. Zener diodes can introduce some electrical noises. We will discuss about the applications of Zener diodes. Voltage regulation. Zener diodes maintain a constant voltage across the terminals. Zener diode is used as a voltage regulator, which means it can produce a constant output of voltage. Now, voltage reference. Zener diode provides precise and stable reference voltage for analog to digital converters such as. We will discuss about voltage over voltage protection. Protection sensitive electronic components by clamping voltage spikes and preventing damage due to excess voltage. We will discuss about current limiting. It helps limit current flow through devices by regulating the voltage and controlling the current. We can conclude that Zener diode is a very important component in electrical circuits. With this, I am concluding the seminar. Thank you.